All right, so welcome back. So again, I like to talk about interactions. So we've got like our interactions between display and position worked out. Let's talk about the interactions of float in this mix. And for the most part, if you're a float, you're going to ignore display. You're not going to really ignore position. I probably shouldn't have put that on there. I might need to update that because you do respect position a little bit. But really, the best way to do it is to figure it up with an experiment, right? So in the same way that we kind of had our 3 by 3 before, now we've got a 3 by 3 by 3. Now it's not really a 3 by 3 by 3 because it turns out that float none is what we studied last time, right? So we already know all of the things in that chart. So, we can kind of take that out of our experiment because we already know how to do that. And then to be honest, float right and float left, they work pretty similar. So if we understand one, we probably understand the other pretty well. So really what we care about is just, how to float right and float left interact with these guys. What we're going to find is that the display turns out not to matter. So really we just have to look at how float interacts with the three different position values. So we're just going to kind of look at those one at a time. So the first one that I want to look at is absolute. So what happens if you have float set and then absolute? Well, it actually turns out that in this case, if you set absolute, then the word float is ignored, right? So in the same way that display gets ignored whenever you do something absolute, float is actually ignored. So the winner, if you combine these two, the winner is very much the absolute. So the fact that you put on left or right, or if you put on none, it just would not matter. So it would ignore them all. So that's kind of the first experiment. So that's pretty easy to fill into our table. It ignored the float, so we didn't learn much about floats yet. So next thing what we've got to do is we've got to figure out for relative and static, what kind of things does it do? So there are basically 6 combinations, and we'll just show all 6 just on the same slide. So first let's do left, right? So if we looked at left and we look at all 6 of these combinations, what do those things look like? So here's what it looks like. I know it's a pretty busy slide, but you can see that here's inline, here's block, and here's inline block, and you can see that they're all identical. The only changes is the screen width when I did the screenshot, but these are all identical. So you can see that display does not matter at all. I said we were going to see that, and we do see that. And these are all static, which means that if you put on like a top or a right, it would get ignored. And then these 3 are all relative, and you can see that float respects the position properties. I was kind of surprised by that. I figured that float would just completely ignore that left, right, top, but it does respect them. And it kind of works the way it did before in that it leaves a box for where it should have been. It then lets you move out of that zone, which is kind of interesting. So it does do the relative things, and that's a good trick to know. So you can slam it to the left, and then you can still put relative on it, and you can move it around a little bit. Just for completeness, I also did it with float right. It leads to the same results that we got before. It's just now it's slammed over to the right. And for no apparent reason, I put relative on this side and static on this side. That was just my bad. But again, the moral of the story is it does actually respect position. I was kind of surprised by that, and I kind of like it as well, so I was happy about that. So to summarize our findings from our experiment, it actually ignores the display property, and then if it's static, it ignores position. That's nothing new. If it's relative, it will respect that position, which is good. Oh, and they do respect their size, which is important. And then if it's absolute or fixed, if it's absolute or fixed, it ignores the float value, right? So it's not a float if you put on absolute or fixed. So it's not a float in that situation. So really, this is kind of a different behavior down here. So how does this fit into what we kind of learned last time? So if I was to say it in words, I would say that if you're trying to figure out what's happening, the first thing you look for is display none. If display none is on there, stop looking. Next thing you look for is if it's out of the flow. So is it absolute or fixed? And if so, that's going to win. And you can stop looking for floats and displays and things like that because it wins, and then the other properties get ignored. If it is not one of those two things, the next thing you look for is float. And if it's float, then you ignore the display, and then you do respect position if it's relative, right? Note that it can't be absolute, because if it was absolute, that would have gotten caught by an earlier rule. So you only had to worry about relative and static. And then if it's none of those three special cases, then you just display as a happy combination. Another way to think about it is as our giant min, right? So if it's display none, you suppress float and position. If it's out of the flow, which would happen with absolute or fixed, then you have display and floats that don't matter at all. And then if you're a float, then you don't care about display. That one's true. And then I should update my image, because you do kind of care about position. So this is the way that this works. If you think about who is the most powerful of these rules, and then if it's none of those, you do some happy combination. The way I actually prefer to look at it is with this table here. If there was one thing that you actually should learn from this lesson, you should learn everything, right? I would learn this slide, right? So display, and then out of the flow. And if it is out of the flow, you're forced to block and none. If you're a float, you're forced to inline block, but you do respect position. And then if you're a happy combination, you fall into one of these 6 categories. So you can see that static ignores position, inline ignores size, and block, you get your own line. All right, that's kind of a summary of all the interactions that we're going to talk about in this unit. You're in good shape. There's one more little thing about floats gone wild, which is not as exciting as it sounds. We'll do that, and then we'll be finished with our layout stuff. I know it's a very long unit. You're doing a great job. Hang in there. All right, see you next time.